Hello, this is Mr. Rasmussen, Algebra 2, Lesson 92. Putting a boat in the river. All right, we got two equations that we're using for this, and it depends which way the boat is going. And we have in parentheses here the boat, their speed, plus the water speed going downstream. This is the same thing, the boat speed plus the water speed is the rate. So really it's the rate times the time equals the distance. We're using the same equation we use for distance problems. Downstream, they work together. Upstream, we subtract the rate of the water because the boat is going against the water and therefore it slows it down. So let's look at example number 1 and work through that there. All right, so example number 1, we have Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were the times? So let's start our equation here. We're going to use the downstream first. It tells us that the boat is going 8 miles per hour. We don't know what the current is. That's our W, so we got to find that out. We also don't know what the time is. We do know that the time of going downstream and upstream, they said, is the same. And then the distance covered downstream is 60. All right, so then going upstream, we have 8 minus the water times the time is equal to, and then that was 20 miles is the distance that they covered. So let's multiply these out, and then I'll write them on top of each other. We have 8 times t plus tw equals 60. Then from over here, we have 8 times t minus tw equals 20. So you can see when you multiply these out and remove parentheses, this one works out really nice because when you add it through elimination, that cancels. We get 16 times the time and 80. And so divide both sides by 16, and it looks like our time is going to be, well, I'm going to do it myself, 80 divided by 16. Oh, our time is going to be 5. So 5 hours is how much time that they spent, and then now putting that back in through substitution, we can find out what the current is. So let's put it back in here. If our time is 5, substituting that in there, let's move our parentheses. 5 times 8 is 40, plus 5 times the current, water, is, oh, I put parentheses back in there. I removed the parentheses. All right, good enough. Equals 60. So subtract 40, 5 times the water is equal to 20. Divide by 5. Looks like our water is 4 miles per hour. Okay, so you write out your two equations and then use elimination or substitution to solve. Let's work through the second example. Second example here, we're talking about steamboat and Juby Fountain. What a name. Could go 70 miles downstream in 5 hours, but it took 6 hours to come back upstream and then to go 48 miles. What was the speed of the boat and what was the current? Okay, so let's fill this one out here. We don't know what the boat rate is or the water, but we do know going downstream it took 5 hours and that went 70 miles. Going upstream, once again, we don't know the boat or the water. We put it in our subtraction, but we do know it took 6 hours to go 48 miles. So let's remove parentheses. We have 5 times b plus 5 times w equals 70. And we have 6 times b minus 6 times w equals 48. Now if we look at this one here, nothing's going to cancel if we add them. So we got to multiply some things. Let's go ahead and multiply by 6 on the top and then 5 on the bottom and then rewrite that. So it gives me 30 times b This is going to be plus 30 W equals, and then we got 420 on the top. Bottom, same thing, 30 times B minus 30W, these ones are going to cancel, is equal to 5 times 48, which is 240. All right, so add those together, I get 60B here is equal to my 660 there, divide by 60 on both sides. The speed of my boat looks like it is 11 miles per hour. Now I got to find out what is the speed of the water. Well, let's substitute that back into one of these. Let's go in this equation here. 5 times my 11 plus 5 times my water is equal to 70. So 55 here. Subtract that from both sides. 5W is equal to 15 divided by 15 equal to 3 miles per hour. So my water is 3 miles per hour. Okay, hopefully that somewhat makes sense there. I'm now going to work through the 2 practice problems, and you can compare that to your work to see if you have this. So, practice problem A. Annie and Patrice could go downstream 50 miles in the same time it took them to go upstream 30 miles. If the speed of their boat was 4 miles per hour in still water, what was the time and what was the current of the water? So let's start filling this out here. We got 4 miles per hour for their boat plus the water for the downstream. And we don't know what the time is, so we'll put a T in there, and that is equal to 50 miles. Then the upstream is 4 minus the water times the time, and that took 30. So we multiply this out, we get 4t plus wt, 4t minus wt equals 50 equals 30. These cancel out, we get 8t equals 80. Divide by 8, divide by 8, it looks like our time is 10 hours. Okay, so if it took 10 hours to go that far, let's plug that back into one of these. Let's plug it back into this guy right here. So 4 minus W times 10 is equal to 30. So we get 40 minus 10W equals 30. So if we subtract 40 from both sides, we actually have equals negative 10. Divide by negative 10, divide by negative 10. W, the water speed is 1 mile per hour for our current. Okay, practice problem B. The sloop Zoli could go 30, that must be a little boat or so, could go 33 miles downstream in 3 hours, but required 4 hours to go 12 miles upstream. We need to know the speed of the boat and the speed of the current. So we don't know what the boat is, and there we go. But we do know going downstream, it was 3 hours, and that's equal to 33 miles. Upstream, 4 hours, and equal to 12 miles. All right, there's set. So let's multiply, let's remove our parentheses. 3b plus 3w equals 33. 4b minus 4w equals 12. All right, nothing's going to eliminate if we add these together, so we got to multiply some things. Let's multiply the top by 4 and the bottom by 3. That's going to give us 12b, and 12b is going to give us a positive 12w and a negative 12w. Those will cancel. And then 33 times 4 equals 132. 12 times 3 equals 36. Let's add these. 24b is equal to 168. Divide by 24. Divide by 24. And it looks like our boat is going 7 miles per hour. All right, what is the current? Well, let's plug it back in. We use the top one here. If our boat's going 7 and we add the water in our equation, 7 times 3 is 21, plus 3w to remove our parentheses. Subtract 21 from both sides. 3w is going to be equal to, looks like 12. Divide by 3, divide by 3w. The water looks like it's going 4 miles per hour. And there are answers for B. All right, let's keep your equations straight. Plug in what you know. Use substitution, use elimination to solve it. And then later substitution. And hopefully it goes well for you. If you have any questions, please feel free to contact me. And have a great day.